Retractable cords were invented for telephone handsets in the late 1930s, and ever since, these coiled cords have been making a lot of great connections. From medical equipment to construction tools to industrial machinery, they keep a lot of things plugged in a very neat way. Retractable cords stretch when needed and spring back into a tight coil afterwards. And that means no tangled knots and wiring snarl-ups, which saves time that would otherwise be spent straightening things out. Production begins with thermoplastic colorant. The color selected indicates the electrical function of each wire in the cord. It takes just a small amount to tin a batch of white plastic pellets, a vivid hue, as they melt in an extruder. Tin-plated copper wire feeds into that extruder, and the colored molten plastic coats the wire to provide an insulating wrap. As it exits the extruder, the plastic casing is still warm and soft, but cool water solidifies it. A spool then takes up the insulated wiring. Next, several wires unwind simultaneously over guide rollers and into a spreader plate. The plate precisely aligns the wires as they feed into a die. This die draws them down to the correct diameter, while a mechanism further down the production line twists the wires into one cord. The cord continues to twist as rollers wrap polyester-backed foil around it. This foil is a shield to protect the wires from electrical interference and is an optional feature. The cord then passes through the twisting mechanism and onto a take-up reel. Next, standard unshielded cord travels through beads of electrodes as thousands of volts of electricity are applied to them. The energized electrodes detect any faults in the wires. If they find none, the cord moves forward. The next machine gives the cord a paper wrap. That's followed by the final layer, a thermoplastic jacket. It also takes a trip through a cooling station to solidify. An inkjet printer applies technical and other information. The plastic casings of some cords have been treated with fire-retardant chemicals. Now they put that treatment to the test. The cord doesn't catch fire, confirming that it's flame resistant. So it's now ready to be coiled. This worker gets the process started by manually winding it around a rod. Then he presses a button and the automated winder does the rest. This establishes the spiraling profile of the retractable cord. But at this point, the coil won't hold. Simply pulling out the rod would cause it to unravel. The plastic sheathing around the wires has no memory, so it won't retain the shape. They wheel the cords, still on rods, into an industrial oven and bake them at 200 degrees Fahrenheit. This gives the cord's plastic casing the necessary memory, so that when the operator pulls out the rod, the coil is intact. But it still doesn't have the necessary snap. That is now achieved by reversing the direction of the coil. The equipment used for that is proprietary, so this worker demonstrates the basic concept with the drill. The drill turns the cord counterclockwise for an impressive rewind. The effect ripples all the way down to the end. Reversing the direction of the coil transforms it. The process tightens the spiral so that after the cord is stretched, it retracts to its original shape. The difference is very apparent. The top coil in this shot hasn't been reversed, while the bottom one has, and it's clearly much tighter. So these retractable cords are now ready to be stretched to the max and snapped right back again.